Right, good morning. So we are on to a new topic today. We are on to some physics. I've explained why in the PowerPoint, but we're on to some physics and we're looking at magnets and electromagnets. So it might seem a bit simple today, but it does get slightly more complex towards the end of the next couple of weeks of my work. So we start with a basic bar magnet just here. Okay, so we start with a bar magnet. A bar magnet has two poles. It has a north and a south pole. A magnetic field is the area around a magnet where the force can be felt, so where a magnet can attract or repel another magnetic object. The lines you can see are the field lines, okay? So a magnet will always have field lines, and field lines always point from north to south, okay? So we have two options. We have when opposite poles and we have like poles. So when we have opposite poles attract, like poles repel. We have these two things here. So here we've got a north and a south, so we've got opposite poles, they will be attracting. We can see that the field lines go straight across from north to south. When we have got like poles, they will repel, and we can see here we've got a north and a north, or it could be a south and a south. You can see the field lines are pointing away from north. If it was south, they'd be pointing towards it, and they push up and away. We can tell the pattern of a magnetic field by using something called iron filings. You'll probably remember these from primary school, or maybe from year 7 or year 8 as well. So when we have those, we sprinkle them around a bar magnet and they will give us the pattern of the magnetic field. We can use a compass to give us the direction of the magnetic field. So we can therefore tell it's going from north to south. If you are aiming for slightly higher in terms of your gradings, so when we use a compass on Earth, it will point to north, but we know that that's strictly not true when we're looking at magnets. They point from north to south. So technically a compass points the wrong way round. It points to the south magnetic pole, which is the north geographic pole. Every now and then the Earth's magnetic field rotates. There is evidence of this in rocks, but yeah, right, you can listen again now if you're not, just a little bit of extra fact. So, why do things become magnetic? Whee! So, what makes something magnetic? We have these little things here, and they are called domains, okay? Domains are like tiny, tiny charged particles. Domains in a magnetic object all align and point to the same direction. In a non-magnetic object, they point randomly. So we have two types of magnet, okay? We have a permanent magnet and we have an induced magnet. So a permanent magnet is a bit more like this one here, okay? So a permanent magnet has domains which are always aligned. This produces a force in a certain direction known as our magnetic field. Okay, so in a permanent magnet, the domains will always look like this. An induced magnet is a material which, when placed in a magnetic field or in a wire carrying a current, can align its domains. As soon as the current or magnetic field are removed, the domains become random again, thus losing the magnetic force. What I mean by this bit here is when placed in a magnetic field. So if we have, for example, a nail, an iron nail, and we put it inside or next to a permanent magnet like a bar magnet, temporarily that iron nail would be an induced magnet. It would have a magnetic field because the domains can be aligned in the same direction. Where I say here, carrying a current, we're going to look at that a bit further on. A wire, when it has a current travelling through it, does have a magnetic field around it. The minute we turn that the current off, we lose the magnetic field. And that would be another example of an induced magnet. You'll have heard of them before, called an electromagnet. We look at them in quite a lot more depth in this unit. Okay. There are a few little exam tips. Last year there was quite a big exam question on it, so I'll give you some exam questions towards the end of the week. But my exam tips are: number 1, magnetic field always goes from north to south. A very, very common error is this here, where people draw the bar magnet, they draw the field lines. You always need to draw at least 2 field lines. This is incredibly relevant when we look a little bit further on at electromagnets. You must always draw at least 2 field lines, okay? So we've got our field lines here at the top going from north to south, that's correct. But then what we've done here is people quite often do that at the top and then do the opposite at the bottom. So if I follow this field line, it's going from south to north, which is incorrect. You would lose the marks. Other reasons that people can lose the marks is they use the word same rather than like. Last year that was an acceptable swap. The year before it was not. So just be aware that don't use the word same, use the word like poles. Always give an example like north and north or south and south, etc. And using the words push and pull rather than attract and repel. Push and pull is key stage 3, so you need to be referring to it as attract and repel. Right, there are 8 questions. There are some questions for you to have a little go at. And then I hope that has been useful. You'll notice I've run out of lined paper. I apologise. I hope this was useful and I will see you all tomorrow. Bye.